These are the 0.3 notes for pre-calculus. Today we're going to be talking about solving radical equations. So for the radical equations, the opposite of square rooting something is to square both sides. So we have here, to get rid of a square root, we want to square both sides. So that usually means you're going to put it in a parenthesis and then put the exponent of 2 on the outside. All right, so let's take a look at example number 1. We've got the square root of x minus 3 equals 2. Just FYI, radical is what's used to describe any sort of root. So it could be a square root, a cube root, a fourth root. All of those are radicals. Most of the time, we're going to be working with square roots. So I'm going to square both sides. The square root and the square cancel, leaving me x minus 3. And then 2 squared is 4. And from here, you would just solve it out, add 3. Now for example number 2, you may want to make sure you move over the 17 to the other side since it's not underneath the square root. Then once you just have the square root by itself, then you can square both sides. Again, the square root and the square exponent cancel each other out. 8 squared, make sure you do 8 squared, not 8 times 2, so 8 times 8, 64. And then we'll solve it out, subtract 72. And divide by 4. All right. So those are the 2 more basic type of problems. And then as we move on to example number 3, we're going to have to add in some factoring. We've talked about factoring already in this unit, but we're actually going to use it within one of these problems. So the first thing we'll do here is square both sides. Bring down the 2x plus 3. And then x squared is just going to be x squared. And then what happens here is we want to move everything to the same side as the x squared. And we want to make sure, do that because we want to make sure our x squared stays positive. So I'm going to subtract 2x. No more like terms over here, so I'm going to just put it in this blank space. At the same time, I'm going to subtract 3. Again, no like terms to line it up with, and that's equal to 0. So we can write it like that. Most of the time what will happen, I'll go ahead and switch it around just because it looks better. But it doesn't really matter. You have it equal to 0, it's still equal to 0. So the step that I just did, definitely optional. All right, now we're going to factor. So you're looking for numbers that multiply to the negative 3 and add to the negative 2. That should be a 3 and a 1. The 3 is negative, the 1 is positive. And from there, then we just set those equal to 0 and solve it. So incorporating a different skill into these problems that we've learned before. All right, so this one actually has 2 answers. Not all these have 2 answers. We know that from example 1 and 2, just having 1 answer. So it just kind of depends on the problem. A lot of times with these problems, one of the answers will be what we call an extraneous solution, an extra solution that doesn't work. I'll actually show you a good example of that on the back side of our notes. But for now, let's just solve the rest of example number 4. All right, so we'll start by squaring both sides. Here I'll have 4x plus 3 plus 33. And now this part right here, I'm going to pull this off to the side right here. And I'm going to have to do it using a little bit extra space. So when I have x plus 7 squared, I actually need to write it out twice and multiply it by itself. This is a process we call foiling, also called double distributing. So you can take the x times x, gets x squared. X times 7, 7x. Then you distribute the 7 times x, 7x. And the 7 times 7 for 49. Then we're going to put our like terms together. So I bring down x squared. I add the 7 plus 7 to make 14. Bring down the x plus 49. And that's what I'm going to write over to the right-hand side. X squared plus 14x plus 49. And then once we have that, then we can move everything to the x squared side. So again, we're going to move everything to the right. Subtract 4x. Subtract 33. Those cancel out, getting you 0, which is what we want. Since we're going to have to do some sort of factoring with this here. Plus 10x plus 16. And again, if you want to flip it around and put the equal 0 at the end, you're more than welcome to. Or if you just want to go straight to the math, straight to the factoring, we can do that as well. So again, numbers that multiply to make 16 and add to make 10. That would be an 8 and a 2, both positive numbers. And then the end, pretty simple. Set each one equal to 0 and solve. There we go. All right, now let's talk about that extraneous solution that sometimes happens. So an extraneous solution is a solution that you did all the math correctly, but then one of the answers ends up not working out. So this following problem has been solved correctly. So notice they squared both sides. And then they must have done this foiling part off to the side. They didn't show us that work, but they end up getting x squared plus 6x plus 9. Then they moved everything to one side. Then they factored it. And I didn't show you those last couple steps of subtracting 4 and adding 1, but here's your two answers, -4 and +1. Another way, we probably would have written it like this as our answers, two separate answers. But they write it like that sometimes in a computer. So what we're going to do is we're actually going to need to check them. And when we check them as two separate things. So we're going to check x equals -4, and then I'm going to check x equals 1. I want to do this two completely separate things. All right, so we're going to go all the way to the beginning of the problem before we did any work. And we're going to plug in the -4 here for the x and here for the x. So it's going to look like this. Plug in for the x. Copy everything else down. And one more time, plug it in. Same number in for the x. So notice I'm not plugging in the 1. I'm plugging both of my x's in as -4. Now let's see what happens. 3 times -4 is -12. And I'm going to add the numbers on the right, -1. Then I'm going to add the numbers on underneath the square root bar to get 1. And then this is just going to drop down. I'm not going to do anything with that right now. And then I don't want to repeat any of the same math that I did before, so I'm not going to try to square both sides or solve it. I'm actually just going to simplify. I know if I take the square root of 1, I get 1. Then again, I'm just going to bring down this -1. And 1 equals -1, that is not true. And we call this an extraneous solution. Because mathematically, we did the work right, but when we check it, it is not correct. So what we would do is we'd come up here and we'd throw this answer out. -4 is an extraneous solution. It got us a non-true equation at the end. All right, let's check +1. 3 times 1. And just carefully do the math here. Add those two together. Add 3 and 13 to make 16. And we're just dropping him down. The square root of 16 is 4. And we'll drop that 4 down one more time. We get 4 equals 4, which is true. Which means 1 is a solution. We've almost checked and double checked that it is a solution. So this would be the only actual answer for this problem. And that happens a lot of the time. A lot of times one of those answers is an extraneous and you would throw it out. Just a note, for Delta Math, the problems that you're going to be working on, they will not have extraneous solutions. So you will not need to check them. Do not need to check. But I didn't want to do this lesson without showing you that sometimes you will have to.